In this video, I'll demonstrate how to create a least cost path in PyCharm using the Python language and connecting to the ArcPY module or the ArcPY tool suite. So first thing we want to do is identify what our task is. So this is the big island in Hawaii and we have a DEM here. And then what we want to do is find the least cost path from point A to point B, which in this case the start point is in green and the end point is in red. We know that there are two peaks on this mountain here and here, on this island here, and we can double check our data to make sure that that looks right. Those are proper units and proper values for that. So now we'll jump over here into PyCharm, the interface I'll be using for this, and we want to import the ArcPY tool suite and then a couple of other things pertinent to that. And then here we'll go through set the workspace and ensure that the Scratch workspace is set wherever you like. I have mine in the same place. We want to overwrite our outputs, or at least in this case I do. That is to say, when we create a duplicate file or rerun a file, does it overwrite it or does it stop the process from executing? Also want to check out the Spatial Analyst extension so we can access these tools. So I'll just run these real quickly and looks good there. So now I want to bring that Hawaii DEM TIFF in, and we'll name it Hawaii DEM, and I'm going to create a slope out of that. So run this, have the output. You can make this a little more concise by naming all your variables at the top, but just for example's sake, I'll put it here. So now I want to reclassify the slope, and that is to say, take a continuous raster surface that we see here and group it so that the classes with higher degree angles will weigh more as we create a least cost route. So here, that's what I'm doing. We have the slope, the input file. What are we basing our value or our reclassification on in the attribute table? Value, and then we remap and we take slope value 0 to 4. That's 0 to 4 degrees. Name that 1 or classify that as 1. 4 to 8, 2, all the way up till it gets really steep. And I just made up these values. You can change it depending on your overall goals. And then go through here and create this as the cost surface. So the reclassified slope will be our cost surface, and we're going to use that in the future. So I'll run this. So now that we have that, there's a bit here where you can add roads or other barriers to your least cost path, and I'm not going to run that, but here's the script to do it, and you can read through that. And basically, it's the kind of thing where if you want to say we have a barrier such as this, how would we navigate? And you can weight the barrier, right? So it's like, all right, well, if the barrier goes all the way across this island, is it worth it to cross the barrier at one point perpendicular to it, or is it worth it to go all the way around? You can weight it in the final calculations. I'm not going to do that here, but if we were to do it and we weighted this road barrier heavy, then we could easily see the path accounting not only slope, but the fact that it would have to run into one of these. So I don't know, just hypothetically, maybe we would see something like from green to red, it might go through here and then hit that if we gave it a high enough weight, right? And it might come around here, going up and then contouring around that mountain. Otherwise, if we don't have this on there, we could imagine, we could imagine that this line will either go somewhere over here or somewhere over here. The computer will know what these individual slope increases and decreases will look like. But here's the script to do that if you wish. First we take the roads, we rasterize them, convert it to a single value, and then add it to the reclassified slope layer, and then that becomes one layer, and that's our sort of our resistance or cost raster. So now we're going to get into cost, distance, and backlink. So we have the input point here, this in-source destination point, the backlink there, and then the output cost distance, which we take the input, and the cost surface, which we created above, and then the backlink file, and we calculate that, and then we save that as cost distance raster, and so forth. So now that that's complete, we can go down here and run the actual least cost path. And here's the call to do that. And then we save it as this object. then we will then save that object when it comes out as a raster. If we want to save it as a shapefile, and then I converted it here as a raster to polyline and smooth it or simplify it a little bit. There's another tool to smooth lines. I always like to print something at the end because it's underwhelming after you get a script to work to have no announcements. If I could have some sort of triumphant music, I probably would, but we'll just run this here and then we'll open it in Arc Pro and see what it looks like. So there we have victory was printed. That means all these other things ran, and we will open this here in Arc Pro and see what we get. So here's all of those outputs that we just created. And let's see, least cost path. So there's our least cost path, which looks pretty good, looks pretty predictable, but it also looks accurate, right? We wouldn't want to have something that looked terribly inaccurate. So maybe we can see a little bit more if we resymbolize this raster. So let's just sort of reclassify it a little bit. Maybe we'll give this 10 groupings, and we can see, let's actually give this 30, and that will kind of help us to see why it did what it did where. You can see this here, it went around this, so it's factoring in distance and slope, and it had the opportunity to go down here, so it did without costing a lot of time and space, or the distance element, and then it headed over here, kind of made a direct line for the endpoint. So hope that's helpful for y'all, and let me know if you have any questions.